Good morning, ladies. How are you? Today we will start with section 2, thin lenses. Okay, so before we talk about lenses, we will consider a flat piece of glass. Okay, and we will shine light on it. We will see how this light will behave. So imagine here there is a light source. The rays are coming toward this flat piece of glass, or we call it like glass slab. So the light enters this glass at an angle. Okay, so the light is passing from where to where? From air to glass. So it's entering a medium which is more dense. Okay, so it slows down in this medium, right? So the light is moving from a medium in which is faster to a medium in which is slower. So it will bend how? Toward the normal. So this is the original path of the light. So it will not continue straight because it changes speed. The speed changes, the speed becomes lower, so it will bend toward the normal. This is the normal, which is the imaginary line drawn perpendicular to the surface at the point where the light hits the surface. Okay, then this refracted ray will not stay in the glass. It will also what? Exit the glass. So here the refracted ray will also move from where to where? From glass to air. Okay, so when it re-enters air, so it will speed up again. Okay, so this is the path of the refracted ray. It will not continue in the same path. It will refract how? Toward or away? So now for sure what? Away from the normal, because it speeds up. So it's going from a medium in which it travels slower to a medium in which it travels faster, so it speeds up. So this ray we call the emergent ray. So girls, here if you compare this emergent ray and the incident ray, what can you say about them? So we can say that these rays are like parallel to each other. See, this is the incident. Okay, if you draw it from here, and the refracted, incident and refracted, they are parallel, just what is shifted. Okay, the ray is just shifted. So the position of the light ray that exits the medium is shifted, but the light ray is still parallel to the original incident ray, because the amount of refraction here is the same of whether light is entering or exiting the medium. Okay, so first the light refracts toward the normal by a specific angle. When it exits the glass again, it will refract away but the same angle. Okay, so this emergent ray is parallel to the incident ray. We'll check this one together. Okay,
light through a glass slab. We have taken a torch and a glass slab. Turn on the torch. We can see that the light ray passes through the glass slab. Initially, the ray hits on the glass surface from air to glass medium. Here, the incident ray refracts inside the glass slab towards the normal. Traveling further, the ray hits the other side of the glass slab and passes through the glass medium to air, and the emergent ray deviates away from the normal. We can see that when the incident ray is making the angle 32 degrees with the normal, and the emergent ray also makes the angle 32 degrees with the normal, thus the refraction of light through a glass slab makes the emergent ray parallel to the incident ray with some lateral shift. Experiments show.
okay, so the emergent ray is the same as incident, it's just shifted parallel to each other. Okay, so now we will start talking about lenses. What is lens? So lens, it's also piece of glass, but pay attention here, it's not a flat piece of glass, so it's a curved piece of glass. When it's curved, so here girls, when each incident ray hits the surface, okay, if you draw the normal will not be here the same for all the points of the surface. The normal, what is the definition of the normal? Normal is the imaginary line drawn perpendicular to the surface at the point where the light hits the surface. So it depends on the point where the light hits the surface, and since here the surface is curved, so for sure the normal will differ from a point to another. So therefore the emergent rays, the rays that exits the glass, will not be parallel to the incident rays. Okay, so here they will be like either like refracted toward each other, okay, refracted inward or refracted outward, okay, depending on the type of the lens used. Okay, so but when light passes through a transparent medium that has a curved surface, which is a lens, the light rays changes direction because the normal line here differs for each spot on the curved surface of the medium. So here we will not have the same direction as in the case of the flat piece of glass. In the flat piece of glass, we said that the emergent ray has the same direction of the incident, same direction, they are parallel to each other, it's just shifted. Okay, but here no, the rays that exit the glass, they don't have the same direction as the rays that enter the glass, because our glass now is curved. So we are talking about lenses. We have two types of lenses. As you can see here, we have converging lenses and diverging lenses. Converging lenses, they are actually girls thicker across the middle and thinner at the edges. We use them in order to converge the light. Look, the light that exits the lens, we use these types of lenses in order to converge the light in, to make it like bend inward. But diverging lenses, they are thinner across the middle and thicker across or at the edges. So a lens, if I want to define it, it's a transparent object that refracts light, such as the rays, they converge or diverge depending on the type of the lens used. So the images formed, you will see that they will be either real or virtual. This also depends on the type of the lens used. Okay, a lens that is thicker in the middle than at the rim or the edges, it's an example of converging lens, and the lens that is thinner in the middle than at the rim is an example of diverging lens. So let's see this visual concept also together about the types of the lenses.
A lens that is thicker at the middle than at the ends is a converging lens. Parallel light rays arriving at the lens are bent when traveling through the lens. All the light rays converge or focus on a single point. The point at which these parallel rays converge is called the focal point. It is to the right of the lens if the light source is to the left of the lens. A lens that is thinner at the middle than it is at the ends is a diverging lens. This lens behaves like the opposite of the converging lens. Although the light rays came from very far away, the lens makes them seem like they all came from a point closer to the lens. The focal point of this lens is to the left of the lens. It is where the light rays look like they originated, even though they actually came from very far away. The way the rays behave after leaving the lens gives them their names, converging and diverging lenses.
Okay, so if you listen to the last sentence, the way the rays converge, or the way the rays refract when they leave the lens, it's what gives them their names. So here the rays, they converge, that's why that lens is called converging. Here the rays after they leave the lens, they diverge, that's why it's called diverging lens. Okay, so here girls, when using converging lens, okay, if we use a very distant object, what you remember about the very distant object? A very far object. Very far object, we said the rays coming from it, such as for example the sun, because they travel very long distance, so the rays coming, when they hit the mirror, they appear to be what? Parallel to each other, because these rays, they have traveled long distance. So when they reach our lens, they are parallel to each other. So always when we have incident rays that are parallel to each other, we know that our object is very far, it's at infinity, we have a distant object. Okay, so these rays, they will refract 2 times. The first when they enter the glass or the lens, the second when they leave the lens. But we care now about this part. So when they leave the lens, they converge. What means converge? They bend inward. So they bend inward until they meet at a specific point. They meet at a specific point, it means here they focus all of them at this point. That's why this point is called what? The focal point. So pay attention, it's different from mirror. The mirror, we said the rays, when they hit the mirror, they bounce back, because the mirror reflect, make the rays reflect, bounce back. Okay, but here lenses, the rays, they can pass, they can enter transparent material and pass to the other side. Okay, so this is just like the example of magnifying glass. So you know the magnifying glass, when you use it outside, okay, and you focus all the rays coming from the sun, and you put, for example, a paper under the magnifying glass, you can burn a hole on the paper. Why? Because all the rays that are coming parallel from the sun, when they hit the converging lens, when they hit it and enter it and then leave it, they bend inward. So all the rays that entered the magnifying glass, they bend inward and they focus at one point. And here, this point, it's just like a real image of the sun. Okay, so they burn a hole because all the light is focused at one point, so big concentration of light, so it burns a hole. Okay, but for diverging lens, if also we are talking about the same case, if we are talking about an object at infinity, so the rays coming from it are parallel to each other, when they hit the lens, they diverge. What means diverge? They bend outward, like away from each other, away from each other. So here, if we extend them, they will never meet. But if we trace them backward, if we trace them backward, they will meet at a point. So here, these rays, they appear to be coming from here, from this source. Okay, so we call this a focal point also, but actually, are they coming from here? They are not. These are the original or the correct rays that are coming from. Okay, but they appear to have originated from this point. Okay, so this is the focal point for diverging lens. So converging lens bends light inward. It can create, you will see that converging lens, it can create either real or virtual image. And this also bears, it depends on the location of our object. It depends if our object is close to the lens or far from the lens. Okay, diverging lens bends the light outward, and for diverging lens, always the image created is virtual. Diverging lenses cannot create any real image. Okay, so if I want to define the focal point, what can I say? I can say that it's the location where the image of an object at infinite distance from converging lens is focused. Okay, so girls, here we said when these rays that are coming from an object at infinite distance, at infinity, they pass through this converging lens and they focus at this point. So this point, it is the image of this object, because these rays, they intersect here. Okay, these refracted are called now, not reflected, pay attention. So these refracted rays, they intersect here. So this intersection, it shows, or it represents the object that they came from. Okay, so for a diverging mirror, for sure the focal point is defined as the point from which the diverged ray appear to originate or to come. Lenses have a focal point on each side of the lens. Why? Because for sure, girls, my object, it can be here, okay? So my focal point will be here. But also, I can put my object from this side and then the focal point will be here, okay? So the object, you can place it in the side that you want. But usually, our object is placed like in the here left side of the lens, okay? Usually this is what we use. So the focal point will be where? Right side. Okay, so we're done for today. I will just show you this visual concept.
The focal point of a converging lens is the spot where the image of an object at an infinite distance from the lens is focused. A group of rays parallel to the principal axis pass through a focal point F after being bent inward by the lens. The distance from the focal point to the center of the lens is called the focal length, F. For a converging lens, the focal length is positive and the focal point is to the right of the lens if the object is to the left. A diverging lens causes parallel rays to diverge. The focal point is defined as the point from which the diverging rays appear to originate. The focal length is defined as the distance from the center of the lens to the focal point. For a diverging lens, the focal length is negative to indicate that the rays appear to originate on the same side of the lens as the object. Both converging and diverging lenses have two focal points, but only one focal length. However, since the convention when drawing ray diagrams is to place the object to the left of the lens, we do not generally speak of two focal points.